A very good morning to all of you, and welcome to the very first EL All Hands meeting in the year 2025. So, according to the minutes from the last meeting, Mr. Anuja Hapukutu was the chairperson and he presented a lesson on state management in React. So, today we are going to dive into an exciting and crucial aspect of modern system design chaos engineering. This is about building resilience into our systems by embracing and experimenting with failure. Let's explore how we can make our systems thrive under adversity. So, these are the topics that we are going to cover today. So, starting from the what is chaos engineering and why chaos engineering, origins and Netflix chaos monkey, principles, controlled chaos in action, tools for chaos engineering, benefits, challenges, and best practices, future, and the summary and takeaways. So, what do you mean by chaos? Chaos means complete disorder and confusion. To start, let's define chaos engineering. It's the practice of experimenting on a system to build confidence in its ability to withstand turbulent conditions. Think of it as stress testing your systems by deliberately creating adversity. This practice ensures we are ready for unexpected real world scenarios. So, why is chaos engineering important? Modern systems are becoming increasingly complex and distributed. With this complexity comes a higher risk of unexpected failures. Chaos engineering helps us identify and address these risks proactively, improving system reliability and our team's ability to respond to incidents effectively. Let me ask you, what would happen if your system lost a critical service right now? Alright, so the concept of chaos engineering was popularized by Netflix, which introduced Chaos Monkey. This tool randomly disables parts of their production environment to test how the system responds. Netflix approach highlights the importance of building systems that can recover gracefully from unexpected failures. For the knowledge, you can see Netflix has a fleet of simian army which are used for various tasks. For an example, the janitor monkey to identify and dispose unused resources, to security monkey to find security violations and vulnerabilities, to doctor monkey taps into health checks and fixes unhealthy resources, latency monkey, uh, conformity monkey. Likewise, there are some heavy soldiers like Chaos Kong and Chaos Gorilla also. Alright, so let's see the principles of chaos engineering. Chaos engineering is grounded in three core principles. First, it's hypothesis driven, which means you predict how your system will behave under stress. Second, it involves controlled chaos, like injecting faults in a structured and safe way. Finally, it's about learning from failures, using the insights to improve system design and incident response. So, what part of your system would you be most hesitant to break on purpose? I might ask. Alright, so let's look at how chaos engineering works in practice. You start by defining the steady state or normal operation of your system. Then you hypothesize what will happen if a specific failure occurs. You inject faults like simulating a server outage and measure how the system responds. The goal is to identify deviations and make improvements. So these are two different pictures but showing you the same thing. Let's go to the left side picture. So it's showing you that step one, the define steady state, then introduce chaos, then verify steady state and roll back chaos. All the time we are monitoring how our systems responds, right? So In the right side, you can see as the first step, know the system steady state, use realistic bugs and failures, test in production, limit the blast radius, and implement continuous chaos. All right, so now let's talk about tools. Chaos Monkey, Gremlin, and LitmusChaos are popular options for implementing chaos engineering. For example, you can use these tools to simulate database failures or network latency. They make it easier to integrate chaos experiments into your DevOps pipeline. What do we gain from chaos engineering? First, improved resilience. Systems become better at handling unexpected failures. Second, better incident response. Teams are more confident and prepared. Last not but least, customer trust. Reduced downtime leads to higher satisfaction. For an instance, companies like Netflix have seen significant benefits from adopting this approach. So, challenges and best practices. Right. Chaos engineering comes with challenges. Teams often fear breaking production systems, and setting up experiments can be complex. To address this, start small, target low impact components first, and gradually scale up. And make sure your team understands the value of these experiments. Then automate them within your CI/CD pipeline for consistency. All right, so looking ahead, chaos engineering is evolving, right? Yeah, we are seeing AI being used for smarter fault injections and expansion into areas like edge computing and IoT too. The goal is to ensure resilience across all types of systems. So, where do you see chaos engineering evolving in the next 5 years? To summarize, chaos engineering is a proactive approach to building resilient systems. Tools like Chaos Monkey and Gremlin make it accessible, and structured experiments help us learn and improve. If you haven't tried chaos engineering yet, I encourage you to start small and see the benefits firsthand. Remember, break things on purpose to learn how to fix them faster. All right, so this is the time for the Q&A session, and thank you for your attention. Now, I would love to hear your thoughts about chaos engineering.